Hey everyone, welcome back to another new video. In today's video, I am going to solve binary tree to DLL. DLL means doubly linked list. And before starting today's video, please like and share. And if you are new, please subscribe. Okay, go to problem statement. In problem statement, you have given a binary tree which will you have to convert it to a doubly linked list means DLL in place, and the left and right pointers in node will be used as previous and next pointer respectively in converted DLL, and the orders of nodes in DLL must be same as the order of given in binary tree, and the first node of in order traversal must be head node of the DLL. Okay, so basically go to this visualization, it will understand what is linked list. And given this is this is a doubly linked list, and this is given a binary tree, and this node are called root node. This is root node, and there are how many subtree? There are, you can see, two subtree. One is this one is this one, and another is this one. There are two subtree, two, or this also a subtree, means total subtree 3. Now we have to convert given this binary to DLL means doubly linked list, and in place converting the doubly linked list, the linked list will be like this. First, what is our leftmost node, because we have to follow the in order traversal. In order traversal means the path of traversal will be left, root, and right. We have to follow this order: left, root, right. And using in order traversal to make the doubly linked list, first it will be the leftmost node. What is the leftmost node in order traversal? We have to consider that. So leftmost node is in this tree 25. So 25 come first, then go to left root. What is the root node? Root node is 12. So 12 second, and then left root right. Right node is 30 in this subtree 30. Then go to next subtree or 12, 10. This 12 already comes, so no need to again write down. So left root is 10, root is 10, so root 10 over here. And then go to this tree. In this tree, left root right. What is the left node? Left node is 36, so 36. And then root node is 15, then 15, and there is no right node, so no need to write anything. And it is the given doubly linked is converting from binary tree. And the first node, this first node called in linked list head node, called head node. And in doubly linked list, this sign is used double direction, double direction. And now if you don't know what is doubly linked list, go to this article, like this article, go to this article, and just remove this. Okay, okay, okay. Now go to this article, and here they have GFG already explained what is doubly linked list and already give visualization. And in doubly linked list, there is two pointer are used. One is previous pointer and one is next pointer, and middle was data node, or first one node called head node, or first node in linked list always called head node. Now in doubly linked list, first there are three parts, you can see. First part is previous node, and last part is next next pointer, previous pointer, and next pointer, and middle are stored to data. And first previous pointer store the address of the previous node, and next pointer is stored the address of the next node. Okay, and given there are, explain the whole of what is traversal in doubly linked list, all of this. So go through this if you don't know. And then given example, they have given this binary tree 132, this 132. Now in this root node is 1, root node is 1. And we have to traverse to make convert it into doubly linked list. We have to traverse using in order traversal. So in order traversal, first which will come first? Leftmost node. So in this given tree, leftmost node is 3. Leftmost node is 3. So 3 will come first in doubly linked list. You can say 3 will come first, then left root. Root node is 1. So then 1, then right, left root right, then right node. And in double linked list this sign is used, this sign is used, by direction this sign is used. And output will be left root right, 3 1 2. Then also they have maintained we have to follow in given problem statement. You can see they have mentioned that given first node in in-order traversal must be the head node of the DLL. So DLL, and it also said in this example, so we will convert this, and first it will first output and next output will we will just reverse it, and 2 1 3, 2 1 3, because we have to traverse both side, right side and left side, so it will be the output, it will be the output. And explanation they have given, DLL would be this. And in double linked list this sign will used in double linked list, also used. Now let's remove it. Okay, okay, now go to next example. In next example given this binary tree, what is the root node? Root node is 10, root node is 10, and there are two subtree. You can see this is one subtree, and this is another subtree, this is another subtree. There are two subtree. Now first we have to consider in order traversal the leftmost of the binary tree. What is the leftmost of the by this binary tree is 40. So 40 will come first, because we have to consider leftmost of the node in the given binary tree. And then left root node in this subtree. What is root node? Root node is 20. So 20, then left root right. So what is the right node in this subtree? 60. 60. Then we have to traverse this subtree. Now in this subtree, what is the left node? Left side node is 20. 20 also write down. So move forward. Root node is 10. Root node is 10. Left root. Right node is 30. Right node is 30. Right node is 30. So we have to arrange in order traversal 40, 20, 60, 10, 30. Now following the order we have to just reverse it, and first will this 30 will come first, 30, then 10, then 60, then 60, then 20, then 20, then 40. Just reverse, and these two three two linked this will be the output. And given you can see this will be the output 20 40 60 10 30, and then reverse 20 10 30 10 60 20 40. This will be the output. And in linked list, doubly linked list, it will represent like this. That's it. Now what is the time complexity of this? Time complexity will be O of n, O of n, because n is the number of the nodes we traverse the binary tree, and both right and left side both. And space complexity will be O of h. H is the height of the binary tree, height of the binary tree. That's it. Just remove. Okay. And okay, okay, now go to approach. And in approach, basically we use the recursion, and using recursion, our time complexity already said O of n and O of h. H is the height of the tree, and O n is the number of the nodes. And we will recursively traverse the binary tree using in order traversal. And what is in order traversal? Already said in order traversal we traverse the binary tree using left root right this way. And then at each node, if left subtree exists, then find the in order predecessor, and then process the left subtree and link the current node and predecessor. Right, if right subtree exists, then find the in order successor, process and right subtree, then link the current node and successor node. And what is in order predecessor and what is successor? Just click on this, and you can see GFG already explained with visualization. Just go through what is successor in this diagram. You can see these two node 2, this subtree in this subtree. This 2 is the successor of this node 5. 2 is the successor of node 5, and 4 is the predecessor. who is the predecessor, and this one is the successor of this node 3, is the successor. Means you can see all subtree root node called successor, you can see all subtree root node called successor, and the right node called, and the sorry, then the left node called predecessor. That's it. Now go to code. In code, basically, we will check if there is no root node, then it will return none, and then we initialize a head node, head pointer to none. Then we recursively traverse the binary using in order traversal. So for that, we will write down non-local head, and if not current, and it will return. And in order traversal, left node will be in order traversal, and then we process the current node, and left subtree go to current node using in order traversal, and then we'll process the current node, and then we adjust the pointer, and why we create this, and because our previous node becomes the left pointer, so we write down current left and equals to self previous node goes to our left pointer, and then our current node becomes the right pointer, so we write down that self previous node and right node, and that's it. And then we mark the current node as previous node, and then we recursively call the right subtree, and then we return the head node. That's it. Now compile and run, and now submit. We solved today's problem. Hope so today's video is helpful to you. See you next video. Till then, bye bye.